Hello, everyone. I am Renata Walker. I'm a senior product manager at Tama, and I'm going to be talking quickly about building a robust automotive LiDAR annotation quality rubric. So, about myself, I been building products for around 5 years from different sides of it. I was previously at Cabello and Breather. My expertise comes from business intelligence, so I'm really crazy about data and building data into products. And currently I manage Tama's data labeling products, both 3D and 2D. So currently we're focusing on 3D vector and segmentation. And for fun, I love playing automatic music instruments and spend time outdoors. I'm from South America, so I love the mountains from Chile. Now, let me quickly go over the agenda for you guys. So, we're going to start talking about why and when do you need a quality rubric. Then we're going to go over the system limits and defining those and how this affect that the quality piece. We're going to be defining quality scoring. We're going to go over the most common error types that we've seen. We're going to talk about trade-offs as well and experimenting with your labeling process. And at the end, I'm going to give you a quick overview of what Sama is, a quick overview of our company. So let's start. Defining the right quality rubric for your 3D LiDAR annotations. Quality is required for your models, and it is imperative for you to have a good rubric so you can attain the qualities that you actually need. So why do you need a quality rubric? If I ask you all, which is the direction of travel of these two objects, what would you answer? Would you say up, to the front, to the side? It's hard, right? So there's so many edge cases and so many specific scenarios where we have to take our perception to make a decision, that it is extremely important for you to have a strong quality rubric that would allow for two people to make the same annotation the same way. So a good quality rubric means that two people with the same information would score the annotation the exact same way. And like that, you can make sure that any errors are easily to identify, and you can also make sure that all the annotations are consistent across all your tasks and all the work that you need to be annotated. Now, when do you need a quality rubric? I would say always. I think it is really hard to identify these edge cases and the expected outputs from the annotations that your model requires. So I would say that it doesn't matter if you're in exploratory research, if you're in research testing, or if you're already doing simple driving. You have to start with a quality rubric from the beginning so you can identify what are your model requirements, and you can also identify what are the edge cases while you are annotating the data. So when it comes to the time that you want to scale and you want to give your annotations to other people, that other people are able to score the annotation the way that you want. So depending on your development cycle, your quality rubric is going to be more robust or less robust, but in time, you're going to be progressing with it. So before we even think about quality or annotations, we have to define the limits of your systems. So what are your system's expected limits? How accurate is your LiDAR sensor data? How that information is with set standards of the quality that you need. So this allows you to know how tight you really need your annotations to be for your model's real benefits. Look at the following considerations to determine the accuracy you would need from your model. So one example is location accuracy, and I can give some real case scenarios where you have amazing LiDAR, you have really good sensor data, density, you have intensity values, but your requirements are to annotate dynamic objects and static objects. So you have parked cars and you have moving cars. For you to properly annotate the parked cars, you want all the annotations to be exactly the same because the car has not moved. If your location accuracy is not perfect, it's going to be extremely hard for you to be able to put all those PCD files together in a way that the car is remaining statically and parked. So you can just drop or a vector annotation, or you can just paint the points in segmentation in an easy way and in a perfect way. If your location accuracy is not perfect, then that's going to jitter. It's going to move around. It's going to go to the one side, to the other side, and the annotators might encounter problems in there and might even like put the cuboid or the bounding box slightly to the left and on the other frame slightly to the right, and that could introduce a little bit of noise to your models. You can catch those errors through a really tight quality process, which is what we do, but it's still noisy. It's still going to be cuboids moving around if your location accuracy is not good. So you have to take that into consideration for your model. The other piece of information is camera calibration. If you who have or you don't have camera calibration, and if it's perfect or not perfect, would also affect the annotators and the annotation. So easily identifying objects is one example. You could easily miss objects if you don't identify that those points that are like very far away are actually a car. Camera calibration will allow you to project those points to a 2D image and help you identify that's actually a car that was missed or that you actually have to annotate. So the different people that are within the process of your data annotation would be able to cut on your errors and on those errors in a much easier way if you do have the right camera calibration. Then other elements that you have to think about is your system's performance. What is the speed in worst case scenario? What is the time to crash in worst case scenarios? What is the HD map accuracy? All of those elements are going to give you more interest and details into what is the exact tightness of the data that you need. How many centimeters, let's say, you have to be from the vehicle. And all of that will help you identify what are the actual requirements that you need from your quality on 3D annotation. So defining quality scoring. What is a consistent method for scoring your annotation? For each class of annotation, you have to define the core attributes that your model truly requires. We can start first talking about annotation instructions. If you decide to annotate specific classes, so you want to annotate vehicles and pedestrians, you really have to identify what do you want to be annotated, what type of information you want to be annotated, what are specific edge cases that you want to be covering. So the example of those cute dogs before, what if the pedestrian that you want, you have given the information that you want to have phase of interest, that it's the direction of travel, but there is someone that is sitting or someone that is laying down, and what are the type of requirements that you want for those specific instructions. Also, do you want instance level information for pedestrians or instance level for vehicles or for other object types? It is imperative that your annotation instructions are clear as water, and visual examples are a really important element to convey the message. The reason behind that is because your annotators are going to be it's going to be really easy for them to know how they should be annotating if they have really clear examples. Then once you do have amazing annotation instructions, we can think about error types. So because all the instructions are very well defined, we can easily identify what are the type of errors that they might be doing. So missed objects, well, I'm going to talk through the error types in my next slide. But in general, it is really important for you to identify the errors and how important these errors are for your model. That's where we talk about quality penalty. What is the penalty that you want to give for each of those errors? Depending on that penalty, you're going to be making sure that the quality is attained as the requirements that you have for your model, and that all the levels of quality are actually well defined as well. So lastly, I would say, how will you score your task, per frame or per video? This can be changed. For example, if you do have object tracking, you want to track a specific object ID. So you decided that your vehicle is going to be instance. So you want to have specific instance of those vehicles. Do you want that vehicle to be tracked across the whole video, across all the scene? If you do want that, then you might be better with per video scoring, because you want to know if that object has been tracked across the video. And if you don't want that, if you don't want object tracking, for example, you might be okay with per frame scoring. So this is also an important thing that you have to consider when you want to score your tasks. Now let's talk about error types. So what are the type of errors that you can encounter? There is a lot of errors that could be annotators attributed, but there's also some other errors that might be introduced by your sensors, noise, or some noise that you can find in your data, in your LiDAR. So one example would be missed objects. Let's say you have a car that is coming in your LiDAR range at the end of your scene, and it's only a few points because it's too far away. There might be moments where annotators are really not seeing those points. So they might forget about those, or they might not realize that those are supposed to be annotated. So that's an extremely important thing to consider. What is the quality penalty that you want for those missed objects? And also, what is the data that you're providing to identify these missed objects? If you had 3D to 2D projection, for example, you will be able to identify all the points that should have been labeled that were not really labeled. Then missed points. Sometimes you can drop a cuboid and the cuboid might not be adding all the points. So if the cuboid moves around and interpolation was not done properly, then those points could be outside of the cuboid or the bounding box, and that would be missed points within your annotation. So what will be the penalty for those kind of cases for your model? Then inconsistent object tracking is what I explained before. If you want object tracking across the whole video, then you want the same car to always have the same ID. So for example, sometimes the car would get out of view of the video or of the scene, and then it's going to come back to the scene. You want those to have the same ID, and you want to make sure that those IDs are properly placed in all the frames. Another type of error is the incorrect direction of travel. So on the example of dogs, if you didn't have that edge case covered and identified what you want to do in those cases, there might be different direction of travels that your model will or your data will have. But if you do have, then it's easy to identify if the direction of travel is actually incorrect. Incorrect cuboid sizes. That's another one, very interesting. Do you want the cuboid size to be across all of your video, or do you want the cuboid size to be set to a specific frame? If you do have calibration data, then it's going to be very easy to attribute the cuboid size to the dimension of the object, because if you don't have enough points to know how many meters you want those cars to be, or those pedestrians, let's say, you still can use a calibration to project the data to your 2D videos or your 2D images, and you can easily identify if your cuboid is too small or too big. And the other way that you can do that is by label type. So for example, if you see some points and you know those points are a truck, and you see that cuboid is actually the size of a sedan, then that's probably something that you want to consider. Do you want that to be a specific measurements if the object type is a truck? Do you want that to be big as a truck, or what would be the minimum size required for that type of object? Then we can talk about incorrect labels. So that will be errors if you tag a cuboid that is supposed to be a vehicle as a pedestrian, or the other way around. Now, these other two errors are very interesting to me. So alignment is an error that we see, raw, pitch, or yaw needs to be correct. So let's give you an example of, you have a car that is moving in front of the LiDAR, and that car is changing directions to the left or to the right. When you're changing directions, the cuboid is moving, but it's also changing the position, right? So you need to rotate that cuboid while it's also moving. That's a common mistake that could happen during annotation, that you haven't really changed the direction of travel while the cuboid is moving. Another alignment problem could come from your data being dirty. So you don't have really good location data and you have stationary objects, and all these objects are, when you put them scene by scene, they kind of like move. They're jittering, even if they're not really moving in real life. So making sure that the alignment is always perfectly attributed to the vehicle could be really important for your model. And sometimes the noise of your data is going to make it really harder for you to annotate without really placing good quality checks and quality improvements when you're actually looking at that data. The other example is jittering. So this would be on cuboid movement not being in sync with the motion of the object. So sometimes the cuboid could go up or down, and if you're going like, let's say like this, up or like in a line, and you don't have really good annotation practices or annotation tools, that cuboid could move up or could move down, and that's kind of like a jittering movement that is not really happening. So you really have to take consideration of that and making sure that the object is actually moving properly. Okay, so let's talk about automating quality scoring. We have something that's called 3D goal tasks, and these have been keen to really identify areas of improvement. So goal tasks are pre-scored tasks that new annotations can be compared against. And like that, you can easily identify when something is wrong or when something is good. Areas to consider for your 3D goal task creation and scoring is, can you create a perfect task by annotating it manually? If you can do that, then great. You can create your goal task and that's it. If you can't, it means that you have to go back to your annotation instructions and quality rubric to make sure that all those edge cases and all those specific things that you're not sure about are defined. Then the second one would be, does your goal task represent annotators' performance on real world data? This is really important. Sometimes you can come up with goal tasks that are using data, open data sets, or data sets that are not really some scenes that were recorded in like not that many pedestrians, not that many vehicles, or like certain conditions, weather conditions, and those goal tasks are not really representing the assets that are actually getting annotated. If that happens, it means that there might be a lot of edge cases that are not like really covered during those processors or when you're annotating your goal task. So you might introduce some errors or some, I don't know what to do here, situations if you don't have them representing real world data. Then another thing you have to consider, and this is extremely important, trade-offs, time versus quality. If you're in the early stages of developing your solutions, speed may be a higher focus as you have more limited use cases or are only testing solutions on a closed testing ground. So define different quality variables that can be adjusted for your model. Some examples will be ontology sizes. So you might not really need to annotate everything, or the requirements on your annotation might be way tighter further down your development cycle, but at the beginning it might be a little bit looser. The other thing, it's label accuracy. Do you really need the 1 pixel or 1 centimeter type of annotation? That will depend on your sensor data and limits, but it also depends on where you are in the moment. Of course, more accuracy will be more expensive. It's going to take more time to make sure that all that data is perfectly aligned to that specific centimeter. The other thing that you have to think about is label attributes. How much information do you really need from your objects? Then I would highly suggest you guys to experiment with your labeling processing. Your labeling process is extremely important for your model performance. So you have to see how your data is looking like, how you want to annotate that, how normal people will be annotating that as well, identifying those edge cases. And it is important that you match your data set size to your development phase. So you don't go and overdo everything at the beginning. You can start small and then start growing and growing and growing and adding more. Also focus on returning results as efficiently as possible at each stage of your development. Like that, you can iterate faster and you can scale and you can have all the information that you need when you're scaling. Then, who should annotate your data? Your goal is to get high quality data as fast as possible for your development phase. So agility is key here. Depending on where you are at in your development cycle, at the beginning, it should always be internal. You should be working with your data, identifying those edge cases, identifying also when your data is noisy and when you have to consider those elements for your model, when you don't have right location accuracy, for example, or like right calibration for the annotations to be perfectly done. Then as you go further down the line on your development cycle, you will want to get a third-party labeling party. Not only because you will need a lot of data for your model, but also because you need the expertise that a third-party labeling partner can give you. We've seen so many times that when we get some data, there's so many edge cases that have not yet to be defined, or there's so many like quality fixes or improvements. And having a strong third-party labeling partner is key for you to have quality because you need all the data, but you also need that data to be really good. So making sure that you involve that third-party labeling partner or a partner to help figure out the annotation requirements earlier in the process is also really important. So you can make the adjustments on your model or on your recordings, and from there you can actually build a really amazing and successful model. So let's talk about Tama. Tama is a company that delivers high quality training data from start to scale. So we really help you from the beginning of identifying what are the requirements for your annotations and nailing down through that quality requirements with goal task creations, with automated qualities checks, and really tight QA. And we are built to scale. So our mission is we provide accurate data for the world's most ambitious AI team, harnessing the power of markets for social good. We have been trusted by Fortune 500 continuously, and we even have a proven executive team with in-depth SaaS and AI knowledge. We've been around for a while, since 2008, and we've been iterating and growing and building our products hand in hand with our customers and our customers' needs. Now, what is this Tama difference? We focus and thrive at quality. We have the highest quality SLA up there. Even in most complex workflows, our team assists with anything from implementing a robust quality rubric to raising edge cases. We are also built to scale. We have machine learning assisted annotation created to get up to 3 to 4 times more efficiency, but it's all focused on annotators. So we're not really doing automatic labels. We're just helping and assisting our humans to be faster and more efficient on their annotations. So we quickly adapt to ramp ups, focus shifts, and edge cases. We change frequency up to 2 to 3 times per week per workflow. And this is my favorite part. We do ethical AI. As an ethical AI company, we have provided economic opportunities for over 54,000 people from underserved and marginalized communities. And this is huge. The work that you do with us has a huge impact in the world. And then lastly, security. We take it seriously. Our tech stack and physical space are really, really important to everything we do. And we have really good uptimes from 99.95% to 99.99. All right, so key takeaways. A good quality rubric enables consistency in your labeling. So again, it enables 2 people to score the annotation the exact same way. Visual examples are really, really important to help convey the intent of your rubric. So you can easily train new annotators on how they should be labeling and what are the specific edge cases that they should be looking into. Then goal tasks are really important to setting a standard for high quality annotations. So pre-score tasks that new annotators can be compared against, and new annotations can be compared against as well. So we can implement also automatic quality checks and make sure that we are getting all those quality elements up till the end and providing amazing quality for you. And match your data size to your development phase. So focus on returning results as efficiently as possible at each stage of your development. So really think through the actual requirements of your data annotations and how accurate you want your annotations to be, because that's going to give you a head start, faster annotations, cheaper annotations as well. Then for complex use case and later stages of your development, you have to make sure to find a partner who can help you raise edge cases and deliver labels with uncompromising quality. And do you want to learn more? You can visit Tama.com. You can contact also sales@Tama.com. And you can also contact me. Feel free to send me an email or anything if you want to talk about error types or things that we've seen. In our experience, we've been working with a lot of autonomous companies. And in that said, thank you and wishing you a really good day.